Yeah, hi again. The inverse kinematics is done and it has calculated all the frames that were selected from Mocha into the TRC file. So what you can see here is let's close this window and let's see the result. Click on play and you can see the kinematics. The complete span of the activity is from 0 to 2.246 seconds, and you can see there is a slight disfigurement in this musculoskeletal model at this time interval. This is because of the error that I was talking previously. So once we filter the data, this error gets nullified. So post this stage, this thing is, or this disfigurement is because of the uh, maybe while recording the data, one or two markers were not visible, as you can see here. One or two markers were not visible properly. So because of that, the kinematic angles for this joint, specific joint, could not be calculated properly. But following this part, it's quite smooth, as you can see. Let me zoom it out. This part is quite smooth. So you already have one stride here. So what we can do is we can directly go to, yeah, before that we need to save this result as a motion file. Save as dot mot. So we are going to use this motion file for further studies. So let's go to the forces and the other forces. Here you can see AACL. The problem with the uh, classes of ligaments that are available in OpenSim is they calculate the length of the ligament or any characteristics of the ligament based on the geometric path, that is the linear distance between the two insertion points. So these are the two insertion points. So and this ligament class that is available in OpenSim, it's a derived class, and it doesn't have the ability to calculate length directly using any of the tools that is available here, like analysis or invert dynamics or forward dynamics. So what, in order to calculate the length of the ligament, what we do is we superimpose the ligament with the muscle. So here what you can see is there is a AACLR muscle with a maximum isometric force of 0. That means this muscle is just a dummy string which is attached to the same attachment point of the AACL ligament, and this is going to be a scale which we are going to use to calculate the length, because muscle class has the ability to calculate length at different analysis. So this is one shortcoming of OpenSim that you can work on in your further uh, studies. I mean, further improvements that we are going to. So let's go to analysis toolbox. So here are a lot of options here. So first thing is we need to load the motion file. So let's select working.mot. As I said earlier, there are crosstalks in this file, so let's filter it at a frequency of 6 Hz. This 6 Hz is a low pass filter. It's a low pass here. You can see the details about it in this part. So, and then click on this part and then select, yeah. So this part is the output part, I mean the directory at which the result will be stored. So you can click here. Let's make a new folder, name it as working. Yeah, it's done. Now it's time for us to select the type of analysis that we want to do. Let's go in edit, add. Since we need the forces developed in the ligament, so we are going to do a force reporter and then a muscle analysis. We can also edit the characteristics of this analysis by clicking on edit, and then define the step interval and other parameters like the list of the muscle list and everything, name of the muscles that we need, everything can be customized here. Let me close it for now, and once you click run, the simulation starts. So it may take some time because the number of discrete points are, I mean there are higher number of discrete points between two time intervals in the data that we have right now. So once the simulation starts, I will just pause the video because there is no point in increasing the length of the video. Well, let me pause it now. As you can see, the execution has started. Executing analysis 4%, 6%. It's gonna take some time. So let me pause the video once again. The analysis is complete, and this is what we get. Let me click here. So let's redirect to this particular folder. This is the folder. So there are a number of files that you can see here. The files that are important for us right now are these two. Other files, the other files can be deleted. I'm just gonna delete them all. Let me open this file. Let's copy this. Let's open Excel. So we are going to paste the video here. Let me paste it here. So let me delete this part initially. These are redundant information that we don't need right now. And here we can plot it. Just select this and then click on insert, click plot. So here, this is basically the characteristics of the activity that we had right now. Force that is generated